Alright, hi everyone. So let's talk about finding horizontal asymptotes for rational functions. And if you see, I have a saying over there, BOBO BOTN eats DC. It's so useful when we're trying to find horizontal asymptotes, right? Especially for rational functions, and that's what they were created for. Alright, so a rational function takes on, alright, you have a function a of x over another function b of x. B of x obviously cannot equal to 0. So where b of x cannot, let's also go ahead and write our conditions, all right? Function over a function, right? Basically, it looks like a rational number, right? Hence, rational function. Now, let's try to find horizontal asymptotes for rational functions, because rational functions, they stem from reciprocal functions, right? It looks like 1 over x. That's its parent function. But the thing is, and they can take on different forms. So we can have horizontal asymptotes in just the same way that we can have vertical asymptotes, which is what another video that I did earlier, all right? So horizontal asymptotes. So if you have Bob, bigger, basically it means bigger on, all right, let me emphasize the O there, on bottom, okay, meaning that the degree in the polynomial, all right, let's see, what's the degree in our, what is it, a of x, or basically the degree in the b of x, that polynomial, meaning like x cubed and all that, is higher than the degree in a of x, the numerator, than the degree of a of x. Then we have a horizontal asymptote y equals to 0. And that's why Bob is actually Bobo. Alright, O represents that this is equal to y. Okay? So that's bigger on bottom, and an example of that is, let's say you have x over x to the power of 4 plus 3, for example. You see, the degree of the polynomial, so this is like our b of x over here, and this x is our a of x. See how a of x, the degree is 1, and the b of x, the degree is 4. So the degree in the bottom is higher than the one in the top. So that's why our horizontal asymptote is y equals 0. Then we have our bot. Okay, so we have bigger on top. Okay, so basically meaning that if the degree in a of x, alright, so now it's flipped, is higher than the degree of b of x, well, we have that, alright, n means that you have no horizontal asymptote. Then we have no horizontal asymptote. No horizontal asymptote. That's why there's an n, right? So that's why it's called button, right? Asymptote. And that's where the n comes from. So basically it stands for no horizontal asymptote. Okay, turning out to be really long. Okay, so see, first so far we have bigger on bottom, y equals 0, Bobo, and then bigger on top, no, so it's bottom, no horizontal asymptote. So we have Bobo bottom, and then that leaves us with eat DC. Okay, and then here, oh, why did I write out each DC? Let me go ahead and say what each one of those are, actually. Let me also give this one a little bit more space. So E stands for exponents, and then A, R, T, the same, all right, and that's what the S stands for. So, and then the DC stands for divide coefficients. Okay, so we have our E, A, T, S, eats, D, C. Right, so if our exponents are the same, meaning that the degree in A of x is equal to degree of B of x, then just divide the coefficients of each. Alright, coefficients. Alright, so for bigger on top, let me also, so I just realized I didn't put an example there. So an example for that one is, let's say, higher than the degree of b of x, so that is x to the power of, let's say, let's switch their spots now, x to the power 4 plus 3 over x. Now what happens here is there's no horizontal asymptote, so you would assume that there's no horizontal asymptote. That's how it would look. So the example is just basically how, our rational functions would look. It's bigger on top, and the degree is less on the bottom because it's x to the power 1, and then on top we have x to the power 4, so there's no horizontal asymptote in that example. And an example where the exponents are the same, meaning that our degrees of the polynomials are equal. So let's say we have x to the power 4 plus 3 over 2x to the power of 4 plus, let's say, 5. Okay, divide the coefficients. So here's our a of x is the numerator, b of x is our denominator. My coefficients are right here. See where the exponents, crossed out the 2 by mistake, where our exponents are the same. Okay, so I have our coefficient is, okay, what's going on? 1 here, alright, so there's like a 1 in front of our x to the power 4, right? When there's nothing in front, the coefficient is 1. And then we have 2. So to divide the coefficients here, if doing the DC part, divide coefficients, it's just basically 1 over 2, and that's just 1/2. So our horizontal asymptote would be at 1/2 in this instance.